Good morning once more.
Good morning, sir.
Yeah. No, today we are studying the practical. It's more exciting. So I would expect each and every one of you to apply themselves. Because I think I requested about 5 lines. So I don't know. All of us are gonna focus on one line. We're gonna do it. Then we're gonna separate into groups of 2. Then we're gonna do it in groups. So the fault is never the same. But firstly, I'm gonna cover the theoretical part so that we can explain each and every component that is on the eye, so that all of us can understand what we are talking about, what their functions are, operating procedure, safety precautions, the common problems that comes with an eye, so that whenever we start fixing or do fault finding, we know exactly where to look at. Are we clear?
Yes.
So I understand almost every one of us is using an eye. So what do you think are the key components of an eye? Can you mention them? Any?
Black.
Okay.
Black.
Yeah. So plate.
Yes.
Element is attached to this plate.
Yes.
Normally we refer to this plate as an element, but this is not an element. Element is attached to this, and it transfers the heat to this plate. Then we use this plate to eye. What else do you think is there? There's also a cord. Yeah, a cord, a wire. What else do you think is there?
Fuse.
Okay, there's a fuse inside. What else?
Plastic body.
Yeah?
The plastic body covering as an instrument.
Okay. What are these for?
Control.
These two.
And find the steam.
For steam, and then in the mud.
Where is the steam coming from?
What?
There's a water tank inside. Yes.
If the water tank is broken,
So
it's good.
if the water tank is broken, when you add some water, it will spill. Understand? So it's another thing. So what else causes the water to spill? Water spillage. Like when the tank is not leaking.
Like when I would assume it's like old seals or seals getting older, so they allow water to pass through.
Okay, that could be another thing. What else?
I know my settings.
Hmm?
My settings corner
Settings.
corner leothi mawuyibeke somewhere amanzi aphuma phansi but phinde uyivale change
Which one is that?
Self-cleans, something like that.
This one doesn't have that function. Oh, the other thing is, here, you can lock the steam. So when you press here, when it's locked, obviously the water will leak. But that's not the only one, there's another one. The other one is the temperature. If the temperature is right, it's not right. It's not hot enough, and when you are trying to release the steam, it will spill the water, to cause water spillage, because the temperature is not right. You have to wait for the temperature to be right, then you can start spilling it. Here, on the switch, it has many different functions. What are they for? It's written here.
To control the temperature.
the temperature.
Yeah, and to choose depending on the type of fabric that you want to sign next. Because when it's what, nylon, wool, starch, so on. Yeah. So they require different kinds of heat. you can't put it on maximum when you are ironing something that is silk. Yeah. So you need to be careful and select the right temperature for the right fabric. Like we mentioned, key components and their function. We have already almost covered that. The key components is the cord or wire, plug. So when you do fault finding, it's important to check if the cord, your cord is not broken anyway. Because like when we did yesterday with the multimeter, we said the functions of the switch is to control the circuit, to put it on and off. So first thing that you do when you do the fault finding, you put your circuit on, you put your iron on, then you take a multimeter, you put it on a continuity function. You still remember the continuity?
Yes.
The one like a speaker.
Yes.
Yeah. So you put it on live and neutral. When it's on, a basic iron like this should be able to come on. It doesn't have any PC board. So it should be able to come on. If it doesn't come on, it means your circuit is open. Then, however, the other thing that you need to do before anything is to verify that this thing doesn't have a short circuit or it's not a factory fault. So you have to check both live against earth. So you're checking the terminal, you're checking between live and earth. If it gives you a reading, what does that mean? It means it's short circuited. So you also check the neutral and earth. So it's not supposed, between earth and any of this, it's not supposed to give you a reading or a sound. If it gives you a sound, you should know it's a short circuit. It's either the plug was wired wrongly or somewhere, somehow, live or neutral is charging with the earth. So it's a short circuit. Then you know that your problem is the short circuit. So, however, if you're getting a reading between live and neutral, that means your iron is working. There's no need to open it. But if you can't find anything here, it means there's something wrong. The circuit is open, somewhere it's broken. So what are the possibilities if you're not getting the reading? What could be wrong?
Switch.
Yes, switch is one of them. What about the wire? What about the fuse? What about the element?
Fuse, wire, element.
Yeah, it could be any of the components inside, but we don't know that. So, first thing that you're gonna do, you can open the top part, this one, the bottom one, the one behind here. Once you open it here, you will be able to access the points, the joints here. So you can take live, you put it on live, and you check it here to trace if the problem is not somewhere on the core. So on the joint, if you are able to get the continuity, it means live, there's nothing wrong with it. Then you come to neutral. If you get it to this joint, it means there's actually nothing with your cord. So your cord is out. It means your cord, there's nothing wrong with it. Forget about it. Then you can continue. Then you can open the other side so that you can access other components inside. Like switches, your fuse, your element are right at the bottom. So you need to remove the top cover and the whole thing. You separate them. Once they are separated, you can test the switch now. Terminals of the switch. Switch it off, switch it on. So if the problem with the switch, when you turn it on, both terminals are supposed to give you a bell. If it doesn't ring, it means your switch is not making contact. So you have to focus on the switch. However, if your switch is giving you a reading, it means there's nothing wrong with your switch. Your switch is working fine. You have to continue. So here's the difference. When we remove the back cover, we were testing from the plug to the join here.
Yes.
But once you remove everything, there's no need to start here because you know already your code is working. Once you open it, now you are testing the components directly. Because you can access the switch directly, you can access the element directly, you can access the fuse directly. There's no need to start from the plug. You only do it on the plug once you have isolated the problem and you resolve it. Ne? Yes. Am I making myself clear or am I moving fast? No. Yes, sir.
I want to ask a question about Ben I8. It's not related to Ben I.
Okay.
I work so much with the hand tools, electrical hand tools, power tools, a drill, circular saw, table saw, everything. Now, ngifuna ukwazi ukuthi khona isikhathi esiningi whereby sithola ukuthi i-problem ama-brush, this leakage springs. So when doing the faulty finding, you can be able to identify using a multimeter what the problem is the brush.
Yes. I think we will cover that properly when I requested blenders, things that have motors, because
Usually
right that those using a motor. So we're gonna deal with the motor and we're gonna explain each and everything about the motor. So we're going to cover that. Things that have brushes, shafts and everything. Yeah. Don't worry. We're starting from the basics.
Alright.
Those are a bit complicated. Okay. So as I was explaining, once you remove the cover, there's no need to start from the plug. You are now testing the components directly. The other thing is the operating procedure. So we have covered almost everything. Oh, the key components. Let me list so that everyone knows what's there. We have a switch that controls the circuit. It opens and closes. We have the thermal fuse. A thermal fuse is there to protect overheating and any hazard fires that may occur. Remember when he said he's bypassing the fuse, I said you might end up burning this solar plate because there won't be any protection provided your switch doesn't open anymore. If your switch is completely closed forever and there's no fuse, this will end up expanding here, burning. So you need to be careful. So this one is there for protection. It protects overheating. Then we have an element. An element is a coil that is attached to this plate. It transfers the heat to this sole plate so that it can iron. So, but they are using a white powder to separate the coil from the metal, because the metal it's automatically attached to the air. So should that metal break and the powder leaks, the coil will touch this and it will cause a short circuit. And inside this one transfers heat. We have a water tank. The main function of the water tank is to store water so that you can make the steam or you can spray a little bit of water when your clothes are dry or things like that. So it's important to understand that. But on this plate, there are some holes here, there are vents here. So when you want to make a steam, the steam comes out through these vents. They are called vents. Sometimes there's some white thing that blocks them. So that's why you need to take care of it and clean it regularly so that it doesn't block or make dirt on your clothes, white clothes. So these are the main key components. So if one of these, a cord or a wire or a plug is faulty, it will affect the system not to work. If a switch is faulty, it will affect the system not to work. If a fuse is faulty, it will cause the system not to work. If an element is faulty, it will cause the system not to work. Water tank won't affect any heat, but people prefer irons that can make a steam. People don't want irons that are leaking water. So, if the tank has cracked, you have got problems. If you are someone who's selling the iron, you need to negotiate because in most cases it's not easy to change it. Which means if you have to change the tank, maybe you have to change the whole cover because it comes in this cover. So you need to be careful about that. So the operating procedure is simple. You just need to choose. It's mainly focused on the thermal switch, choosing the right temperature for the right type of fabric. That's the most important thing. But what are the safety precautions? What do you need for this thing to remain safe and not cause any problem or accidents in your household? What do you need to do? How do you take care of an iron? Whether you are using it or after use. What are the safety precautions?
If you use it, make sure you put water.
Yeah, that's one thing. Then when your iron is plugged, never leave it unattended because you never know. It might fall on top of a soft thing, then it causes fire.
Yes.
So never ever leave it unattended when it's plugged. Even when you are using it, ironing it, don't just put it anywhere. Put it on things that are heat resistant. When you're ironing, don't put it on top of a plastic. You might cause accidents. Even after use, wherever you store it, be careful, or you wanna store it where there's heat resistant, or let it to cool off before you put it in your wardrobe or anything. So you need to be extra careful. So that's your safety, because there are a lot of accidents which were caused by an iron. And then the last part is the common issues of an iron. What are the common things that you know? Personal.
Water leakage.
Okay. Common problems, common issues, common problems. Water leakage.
Switch.
What about the switch?
It comes off.
Turns off. Can't turn on, can't turn off.
Switch comes off.
Things is loose. Sometimes it's
Fuse
comes
cut.
out.
This
Yes.
lever here,
Yes.
it comes out.
Yes.
It's plastic, this thing, though, it can break.
So as far as it comes out.
Is that a common problem? It's not common. Yes.
Damage fuse, overheating,
Yeah.
overheating, burning clothes, damage fuse.
Okay, burning clothes. Or overeating. Uzo. Your hand was up.
Now, from a Russian side,
Hmm?
it happens with umuntu oyilokhoza leyo phansi ibiyenza ingubo zibe wawacha ayina kuzibe dry zibamba kanti uthi ayina ayihambi qho
Stick.
stick
Singaqiniwe.
Oh, yeah, sticker. Okay. You were like, burning clothes, sticking. Common problems. What do you think? This?
Switch not functioning. Because when you
You can't control. I am if I getting more heat.
Yenza more heat.
Toti iswishi ayisakwazi ukwehlisa heat.
We can just say start switching.
Yes.
Let me ask, have you ever seen an iron that light comes on but there's no heat?
Yes.
Why don't you mention it?
Common leyo. I feel it. Tom yam suthi
Lapho inkinga sokuyilo iplate. Ngoba phela usuke ingashisi kodwa isuke ikhombisa ukuthi iyahot. Futhi akuyona inhlabi, akuyona intambo.
Element. Or if the light comes on but there's no heat, it's common. Or it doesn't come on at all. No power at all.
intambo ifike.
Okay, let me ask questions. When there's no power, what do you think might be the problem?
The cord.
You are just assuming.
No. Pela, if you plug it in, you expect when you switch on the socket, immediately there should be power, right?
And there's nothing wrong with your socket.
Yes.
So it doesn't come on.
Yes. So if
What do you think might be the problem?
Fuse.
Wires.
I'm not saying what you are saying is wrong, but you are assuming.
I did revive the
So, he was talking about a series connection. He was talking about the series connection. So, if something has components that are connected in series, if one component dies, whether it's the one from the beginning or at the end, if any component dies, it affects the whole system.
the circuit is not on.
Because the circuit is now open. So when you say it's the switch, when you say it's the fuse, or when you say it's the cord, you say it's the fuse, it's assumption because it's more than one thing that can die. So you need to list, or it can be certain components, certain number of components that affect it. I'm not disputing the fact that it could be a cord that affecting the power. I'm not disputing the fact that it could be a fuse, it could be a switch, and it could be an element. I'm not against that. But when you say it's a fuse, well, that is an assumption. Because you're not telling us the whole truth.
I'm so offended.
You had a question?
No, sir, no.
So, in order to answer some of this, because I'll just draw a circuit diagram for an iron.
Yes.
How do I draw this one? Let me make a black man. Let's say life, no black. Then we have an M here. So from life, we are having something like a switch. Then we are having a fuse. Then it goes. When it gets here, on one side we are having an element. On one side we are having a lamp. Am I missing anything? So here it's a neutral wire, it's a live wire. We have a switch, we have a fuse, we have an element, a bulb, So we are saying a complete circuit, it starts from live, it ends on neutral. So everything else has to be there, has to be functioning. If any of these things on this thing is not working or functioning properly, it affects the whole system. Only these two, a light and an element, only those two are connected in parallel. They share the power. Bear in mind, a light, for as long as the light is connected in parallel with the element, it always has a resistor here. A resistor is there to reduce amount of current that flows through it. Okay? But in most cases, we don't talk about this. It's never a problem. Okay? So now what we are saying, something that affects the power. If the cord is broken, it affects the whole system, which means the power won't flow through here back to here because it's broken. So which means the fault that you need to identify is to identify that there's a cord that is broken, so the current won't be able to complete the circuit. Again, you tell me, if the switch is always open, you close it, you switch it on, but the switch doesn't close, doesn't make contact inside, your circuit is always will remain open. And when your circuit remains open, there's no way current can flow in an open circuit. A switch could also be the problem. A fuse. If your fuse is broken, there's no way current can flow in an open circuit. However, we are coming to the second point from the bottom. If your element is broken, what will happen? If it's the only element that is broken, what will happen? Yeah? But what will happen?
The iron could be on.
Thank you. The iron, if it's only the element that is broken, when you switch it on, the light will come on, but there won't be any heat, which is what he said is a common problem. The light will come on because the current will flow. Here it's parallel, which means the current here splits. The other one goes this way, the other one goes this way. They combine here, then they come back. If this one is broken, the light will come on. So, this is a common problem. If you see an iron coming on, more especially a basic iron, you see a light coming on but there's no heat, just know this one is not an assumption, it's a fact. That's when the light comes on and there's no heat, it's the element that is broken. It's a fact. Go home, go into the drawer and check all the irons that the family had. Switch it on. When the light comes on and there's no heat, just know that you need to throw that away because the element is broken. Unless if you can get a replacement, you can fix it. But if you can't find the replacement, just know that it's done.
Damaged.
The same thing happens. If the light is the light that is broken, what will happen?
The element will still produce heat. Yeah.
So the element will produce heat, but the light won't come on. Why? The reason is simple. The element and the light are connected in parallel, not series. However, everything else is connected in series. So if it's the pot that is broken, it affects the whole system. If it's the fuse that is broken, it affects the whole system. If it's this, it affects the whole system. Unless if both of them are dead. Sometimes it happens that both, not this one, not both. One thing that I did not talk about is the fuse. What happens if the fuse is broken?
Overheating is bound to occur.
The fuse is broken. What will happen?
The circuits will be open.
The circuit remains open.
The circuit remains open. Once you switch it on, there won't be any power. It's also a common problem. This is a common problem. Most irons, I believe this is one of the common problems. When you switch it on, the light doesn't come on, there's no power. The most common thing is the fuse. The fuse is blown. So, most of the people that you see around fixing irons, simply what they're doing is to replace the fuse. In most appliances, what dies is the fuse. The fuse is there for protection. So when anything goes wrong, the fuse is the first thing that dies to protect your appliance. However, don't just assume that it's the fuse that is dying. There's a cause. When the fuse dies, bear in mind already there's something that caused the fuse that caused the fuse to die. So you must always make research. I always tell people to say a switch in most cases. Okay, it's overcurrent that causes the fuse to die. The most common thing is the switch. You see, your switch, your contact points of the switch, when they stack together, when the switch senses there's too much heat on the iron, it's supposed to open. But when it's stuck, it doesn't open. It remains closed. Then what will happen? Instead of the element burning, the fuse will die. So what do? When you replace the fuse, always make sure that you clean the terminals of the switch. Always. With a sandpaper or a metal, flat metal that can go through those points of the switch. Always. Failure to do that, once you replace the fuse, it's gonna blow again because the switch will remain closed. And something that you should put in mind is that when the contact of the switch are completely closed or are stuck together, even when you turn it off here, the iron will remain on. If you don't realize that, it's gonna burn the fuse again and again. However, but there are those who fix on the street. They don't go and buy a new fuse. They make a wire here.
Bypass.
They bypass. Obviously, they've created an alternative route, but that alternative route doesn't have safety in it. So once you bypass it, which means the only thing that is gonna suffer is this plate here. The element is gonna burn this plate because there won't be any switch or any fuse that come to rescue it. So that it's important. Whether you change the fuse or you bypass it, clean this surface here. So once you clean it, you are creating a safety for your element. So it might take 5 years more before this one starts again. So, but if you clean it thoroughly, it might take close to 10 years. Nobody will ever know that you bypass the fuse. But just know that where it's gonna start, it will affect the element. Unless if you are lucky the element dies a natural death before this one. Are we clear? Yes. Any questions? So things like stack switch, we have covered that. We have actually covered this three. But when your iron is sticking or burning clothes or overheating, that one is something that you need to do to take care of your iron. So regularly, other irons have a function for self-cleaning, but regularly what you need to do, you need to clean this damp or damp cloth. Others are using No, steel wool is damaging. You don't have to damage it. You know what you have to use? Use jig, dishwasher. You mix them in water. You can use the sponge, but what you need to do is to plug the iron on. When it's warm, it's not even warm. When it's hot, take the cloth, the water, and clean it. Yeah. Be careful not to burn yourself. Do that, it will remove all this. Others, what they use the grandpa peel when it's hot. Yeah, but I prefer the jig and the dishwasher thing. Just be careful not to burn yourself. Questions?
No.
Because from now on going forward, we are gonna do the fixing. So what we're gonna do, we're gonna start, all of us are gonna focus on this iron. We're gonna use the multimeter. The multimeter is gonna tell us where the problem is. Yes. I'm not sure if this thing is faulty or they made a mistake when they tested it. But it's supposed not to work. So we're gonna do this as a team, and then from there we're gonna separate in pairs, then we're gonna do it in pairs.
Yes.
Yes, sir.
Hey, sinenkinga thina la emakhaya. Uthi ase ubona i-screwdriver
Khona khona yabo la nhloni. Kunama-screws uthi just nawo ama-screwdriver ukwaqaqa. End up sesibreaker le nto le.
Hey, and one other thing, the trick about the iron is its screws are hidden all over. So they didn't make it easy for someone to open it. Yeah. But as a technician, you must find a way. Don't break someone's iron. Find ways to open it. Look for screws everywhere, hidden screws. They are hidden all over. They differ from iron to iron. And never ever make a mistake of plugging an iron on the power without testing it with the multimeter. You never know what's going on. Ne?
Yes, sir.
Don't make a mistake of testing it without putting the switch on. Because if the switch is off, your circuit automatically is open. You're not doing anything. Between the life and egg, there's nothing, which is removed short circuits. So now it doesn't have a short circuit. Then what about between life and neutral?
We have power.
What does that say?
The cord isn't.
Oh, come on, guys. Come on.
What is continuation?
Come on. Come on. What does that mean? The circuit is closed, which means this iron is working. So they gave us a working iron. And now you are saying this thing is open.
Let's pass forward. Okay.
So if it does like it, we have checked or it doesn't have a short circuit. Now can we plug it in on the cord and prove it whether it's working or not? But there's one thing that you didn't do. You only checked it when the switch is on. You never put the switch off to check. Does it switch off?
switch it off and see. Off.
Something is switch it off.
Are you switch?
It's very open in this circuit.
So you value and
So far, I'm seeing
Ukuthi yona ucishe.
There's nothing wrong with it. Even this one, I'm not sure. Let's first test with the multimeter and check this one.
Yeah, pass out the fresh.
I have my own doubts.
so does it work?
So this switch,
Did you switch it on?
Yes. Yes, I can.
So we have a closed circuit.
It's not open. Actually, I don't know.
And this is valid for so that's delay is always closed.
this is shabby.
Let's pass another.
I saw shut up.
Sithola bona wegcina ukugcina thina sengabe mabeka shuthi sokuhamba uphilayo
Yes.
hayi ukuthi isanda iphuphu ithekaneke nje kanjalo
I wish they were just collecting them without testing.
It's a fresh.
boss nane
Yeah, currently.
But you can see what the multimeter tells you. So it can save you a lot of time.
sengifike ngajela ngingenzanga lutho hayi 250 umuntu esazomhlafuna nje wena ngoba sakhe ngesikhathi phela ngemali yasefe komele impela hayi azama
Yes,
Don't put on the plastic.
plastic.
So since there were 5 holes,
Aspanao.
sekulindona usizo ziyashisa nomoya abanye kodwa ngiphathele bazi ukuthi afike
Can we not modify like a break? Say put it in a way it's plug. So since when the situations like this, we just gonna let them cool off. Then we're gonna take one, open it, just to see the exact components how they look and I've requested 5 for each, 5, 5, 5. All 5 are waiting. I actually have hopefully the curtains are broken.
Information